Hello, class 12. We're going to look at the product rule. And so this is a situation where you have one function of x multiplied by another function of x. So if you want, we can write a little caveat over here. This is the product rule here, where u and v are both functions of x. Okay, so what the rule is you differentiate, so you have the two things. So here's the first function of x, here's the second function of x. Two things multiplied by each other, they're both functions of x. You write down the first function of x as it is, then you differentiate the second function of x, then you write the second function of x is, and then you differentiate the first function of x. So let me show you how it works with an example. So let's do this one the old way. How would we normally do this one? First of all, you would expand your brackets and go, well, that's 6x squared minus 14x. Then we differentiate that and we'd get 12x minus 14. Let's have a look at the same question, but we're going to do it using the product rule. So we'll start off with the question again, 2x outside of 3x minus 7. So here's my two functions of x. Here's some function of x multiplied by another function of x. So let's follow through the product rule. So the product rule is the derivative is the first function of x. So that's 2x, the one that we call u. Actually, I'll even write a little u above that. That's the u and that's the v, okay? Multiplied by v dash, or the second thing differentiated. Well, what's the derivative of 3x minus 7? It's just 3. Plus, let's go back over here. It says v, or the second one. So v is 3x minus 7 multiplied by the u, which is the derivative of the u, which is just 2. Now, if we clean this up a bit, we get 6x plus, and let's expand those brackets, 6x minus 14, clean it up a bit more, 12x minus 14. So we see we get the same answer both ways. That's using the product rule. So clearly when we're doing something like this example, you wouldn't use the product rule because it's easier just to follow what you've done before. But let's have a look at something where you do need to use the product rule. So let's do another example. What if we had something like y equals 2x, no, not that one. Sorry, that's what we just did. Y equals 3x outside of sine of 5x. Now, you haven't been able to do this before. What you can see is you've got, here is a function of x and here is a function of x, and they're being multiplied by each other. So that's like your u and that's like your v. So let's go ahead and do it. Y dash. So u comes first. So that's 3x. Multiply by the derivative of v, the second bit. So the derivative of v is sine goes to cos, remember? Cos of just what it is, and then multiplied by the derivative of what's inside these brackets, which is 5. So I'll put that out the front. So that's only half done. I've done u, v dash. Now I need to do v, which is sine of 5x, multiplied by u dash. So what's the derivative of 3x? It's just 3. And so you would just write it a little bit tidier together. Hang on, whoops. I didn't tidy that up. 3 times 5 is 15. It'll be 15x cos of 5x plus, I'll just stick the 3 out the front because that's usually where we put it. Okay, let's do another example. What if we had something a little bit more complicated? Let's take something like this. Y is equal to e to the x, and then I've got the square root of 3x squared minus 8. Put that up there. So again, we have a product. We have two functions of x. We have two functions of x. This is the first one, multiplied by the second one. So that's our u, that's our v. So let's use the product rule. We'll put dy dx this time, just to remind you that you can use both notations. We want u and then v dash. So the u is just the e to the x. V dash, oh, hang on. Sorry, I want to be able to get my, I'll rewrite it first. Apologies. Before I do anything, I need to write it, my square root, in a form that I can differentiate. So there it is. I've rewritten with the power of a half. Now I'm in the position to do dy dx. Dy dx. And I've still got my u and my v, the first bit and the second bit. So u is e to the x multiplied by the derivative of v, v dash. So I bring my half down, write what's inside the brackets, reduce my power by 1, so a half goes to minus a half, multiplied by the derivative of what's inside. So the derivative of 3x squared minus 8 is 6x. Okay, then I need to add plus v comes now. So v is the 3x squared minus 8 all to the half, multiplied by the first thing, the u differentiated. Now e to the x just differentiates to e to the x. And so there it stays. Now you can clean it up a little bit. So a half of 6 is 3. So we'd have 3x e to the x, 3x squared minus 8 all to the minus a half, plus, let's usually stick the e to the x out the front, 3x squared minus 8 all to the positive a half. Now, you know, in the back of your textbooks, they often rearrange things a bit more, but in essence, that's what you need to do. So then you're doing exercise 7J, page 322, and just choose a selection of questions.